Good morning, Geometry Honor students. So Mr. Chen again. So this one is for the continuations of the special properties of the parallelogram and applying the properties of the parallelogram to solve for x, y, finding the missing length, the angle, and also for the proof. Okay, so we'll take a look at that here. So let's start out with some of the warm-up problem here. So this one's, some of those are pretty basic. You guys can just find out what those are, the missing angle. But let's do the one with the ratio. So the measure of angle A and B are of a parallelogram ABCD. Okay, so draw the parallelogram first. Okay, so this one, ABCD. So we do know that the measure of A and B, so the ratio for that is considered 2 to 7. 2 to 7. And find the degree of the measure of angle A. So one thing that we notice, the sum of those two angles is always considered supplementary angle, because that's one of the properties of a parallelogram. So the total ratio here, that would be considered 9. Okay, so in order to get that angle A, so that would be considered 180 times 2 over 9. And also, in order to get that angle B, so this one will be using ratio, proportionality, so 180 times 7 over 9. So 9 goes into 180 20 times, so 20 times 2, 40. So angle A is 40 degree. Angle B, 9 goes into 180, 20, so it's 140 degrees. Okay, so that's how you come up with this. And then the rest of this, quite similar to what we've been doing, solving for xy system equation, but the thing is that we have to apply the properties of a parallelogram. So again, in other properties of a parallelogram, the opposite sides, they're always congruent. So 2x plus 4y, so that equals 6y plus 1/2 x. Another thing that we notice, 3x plus 3y, the other two sides right here, they're considered congruent. So this one, first equation, we can simplify it a little bit. So x plus y equals 7, because what I'm doing here, divided by 3 on both sides. So let's give the name first equation. Second equation, so this one, so 2x minus 1/2 x, then that you'll get 3/2 x. 4y minus 6y minus 2y, so that equals 0. If you don't want to deal with the fractions, you can always multiply by the least common denominator, multiply everything by 2. So what we found here, it's considered 3x minus 4y equals 0. So 3x minus 4y equals 0. Second equation. And then solve for xy, going back to algebra 1, so system equation. So multiply the first equation by 3 or positive 4, depends on what you want. So multiply the first equation by negative 3. So we got negative 3x minus 3y equals negative 21. Combine it with the second equation. So once you combine it, so negative 3x got cancelled, so negative 3y plus negative 4y, so that would be considered negative 7y. So negative 21 plus 0, that's negative 21. Divided by negative 7, so y equals 3. So once you solve for y, then you can solve for x. So solve for x, plug in back to the first equation. So x plus 3 equals 7. So that means x equals 4. So it's pretty basic. So the other one is quite similar. So just set up the parallelogram and then label it, and then you want to set up that the equivalency with that, the parallelogram. And this one saying that the perimeter of parallelogram ABCD is 180. So once you combine those 4 line segments, so you'll see that it's considered 180. And also the opposite side, obviously got to be congruent, so we can set it up. Okay, so let E be the intersection of segment AC and DB. So let's just make the diagonal, DB, AC. So let this point of intersections, so let's call that point E. So one thing that we notice, AE, it's 2x, EC, it's y plus 7. So one thing that we notice, So anytime they have a parallelogram, the diagonal, they always bisect each other. So 2x equals y plus 7. And then DE, this one, DB, the entire diagonal. So x, which is considered half of 31 minus 7y. Okay? So in other words, 2x equals 31 minus 7y. Again, solve for x and y. So this one can use substitution, 2x, 2x. So that means y plus 7. So that equals 31 minus 7y. Okay, so solve for y. So S7y both sides. So we got ay, 31 minus 7. So we'll get 24. And then y equals 3. And then solve for x by plugging the number back to the first equation. So 2x equals 3 plus 7. So 10 divided by 2. So x equals 5. Again, pretty simple. And then another properties of a parallelogram, if this one is the diagonals of the rectangle or the parallelogram, so that means the alternate interior angles, they're congruent, and also the opposite angle got to be congruent here. So y minus 8 equals 1 4x, and then 4x minus 8 equals 8y minus 12. And then basically just reset the equations. It depends on what you want. Substitution, elimination, you can always do that. Again, if you don't want to deal with the fractions, you can always multiply by the least common denominator. So multiply by 4 both sides. So we got 4y minus 32. So that equals 1x. And then this one here looks like everything is divisible by 4. So divided by 4 here. So we got x minus 2 equals 2y minus 3. In other words, x equals 2y minus 3 plus 2, negative 1. So again, the x, we can just set that 4y minus 32 equals 2y minus 1. So 4y minus 32 equals 2y minus 1. Subtract 2y both sides, so we got 2y. Add 32 both sides, so we do have, well, add 32 both sides, so we do have 31. So solve for y, so y equals 31 over 2. And then solve for x by plugging the number back to the one of the equation. So 4 times 31 over 2 minus 32. So 2 goes into 4 twice. 2 times 31, so then that'll be 62 minus 32. So that'll be considered 30. Okay, so for x equals 30. And then for y equals 31 over 2. So determine the value of x and y for which ABCD is a parallelogram. Again, similar to what we were doing. So consecutive interior angle, it's always 180. So 2y plus 3x minus 40 equals 180. And then opposite angle right here, they're considered congruent as well. So 2y equals x minus y. And then solve for x and y. So once you set up the equation, you just applying the linear system equation solving technique, either using elimination or substitution. So complete the statement for the parallelogram BCDE, then state the definition of a theorem as the reason. So BZ is parallel to ED. And the reason why that is the properties of a parallelogram. Complete the statement for the parallelogram FGHI. Say the definition of theorem as the reason. So FO, okay, so this one is congruent to HO. Again, if that's a parallelogram, so that means the diagonals, they always bisect each other. So CD, so this one is parallel to, congruent to EB. Again, special properties of the parallelogram. Okay, so this one, angle K is congruent to Angle K is talking about this one. It's congruent to angle I. So parallelogram, opposite angle, they're always congruent to each other. Okay, so now let's do the proof. So given that parallelogram ABCD, so BF is perpendicular to AE. So BF is perpendicular to AE. CE is perpendicular to AE. So start with the given. Okay, so again, I'm not going to rewrite that. So we do know the parallelogram. So if those two line segments are perpendicular, so that means the 90-degree angle could be formed. So angle BFA equals 90 degree, and also angle CED 90 degree. Definition of perpendicularity. And then also you can state that angle BFA is congruent to angle CED. Definition of congruent angle. Another thing that we notice, if this one is a parallelogram, so that means the opposite segment got to be congruent. So the opposite segment here. So what we found, so AB is congruent to CD, property of a parallelogram. Okay, so now let's see what else that we have. So this one, well, if that's a 90 degree, so here's another thing we can show. So we can use that the hypotenuse and leg theorem to show that the congruent triangle is congruent. Okay, so here's another thing that we can do. Let's see. So we got 90-degree angle. So we got the hypotenuse. And let's see what else that we can show right here for the parallelogram. Okay, so the angle. So as you can see that this angle here. Okay, so angle A is congruent to angle CD. And the reason why that is because that it's considered the corresponding angle. I'll just state that with the parallel segment first, okay? So before we state that angle A is congruent to angle CDE, so let's say that segment AB, so statement number 5, it's parallel to segment CD. Again, properties of the parallelogram. So if those two line segments are parallel, so we do know that this segment AE is kind of like a transversal. So therefore that angle BAF is congruent to angle CDE. Okay, if two line segments are parallel, what happens with the alternate, the corresponding angle? Definition of corresponding angle. So now, one thing that we notice, so that means triangle BAF is congruent to triangle CDE by using angle psi right here. I mean, you can use hypotenuse and leg, but the thing is that the leg, we're not quite sure about the leg. So therefore, segment AF is congruent to segment DE by using CP, CTC. Okay? So here's another one you guys can prove that the diagonal of a parallelogram bisect each other. So the thing is that using the properties of a parallelogram, so this one's just giving the hint. So in order to prove that the diagonals of the parallelogram bisect each other, so we can always use that proving the triangle. So the triangle that they're congruent, like this two triangle here. Okay, and then we can show that the segments they're congruent by using CP, CTC. So using the special properties of a parallelogram: alternate interior angle, opposite segments, they're congruent, vertical angle. Okay, so this one could be proved by angle psi again. Okay, so try that with the proof. And then here's another one. So ABCD is a parallelogram. So BP is congruent to DQ. So in order to prove that X is the midpoint of AC, so we need to show that AX will be congruent to CX. Okay, so that means we need to prove those two triangles congruent here. Okay, so there's two triangles congruent. So in order to show that those two triangles are congruent, so one thing that we notice, so BP is congruent to DQ, and we do know that AD, I'll start with that ABCD, is a parallelogram given. So using the properties of the parallelogram, so we can say that segment AD, not AB, is congruent to segments CB. Again, properties of the parallelogram. Okay, so once we get this one, and then we can just combine those two segments together. So that means AD plus DQ, so that would be considered AQ, and also the other one showing that CB plus BP, so that would be considered CP. So this one will be considered segments addition postulate. So for both statement 3 and 4. So we got the segments here, so showing that they're congruent. And what else that we can show here? The angle. So angle A, well, angle QAX, or angle DAX, the same angle, it's congruent to angle PBX or BCX. So this one, you want to say that it's considered the alternate interior angle, because we do know that AD is parallel to CB, so those two angles got to be what? Alternate interior angle, congruent. And also angle AXQ is congruent to angle CXP. So this one is by the definition of vertical angle. So therefore triangle AXQ is congruent to triangle CXP by using angle psi, and then using that CP/CTC, so we can say that AX is congruent to CX. And therefore, by the definition of a midpoint, so we can say that X is the midpoint of AC. Alright, so this one is just one of those proofs. Well, it doesn't require that 10 statement. I can add on one thing here, the segments that they're parallel. AD is parallel to BC, so we can show that the alternate interior angle. So if you want to add it on. Okay, so that's it for this second part of the properties of a parallelogram lesson. So thank you for watching the video. So I'll see you guys next time.